Okay, great. Yeah, hi everyone. I'm Raghav. I'm a PhD student at UC San Diego, currently at CERN with the CMS experiment. I'm very excited to talk today about this library we've been developing called JetNet for developing and reproducing machine learning projects in high energy physics. So a similar area as the last talk. And thank you to all the organizers for this amazing workshop. I've learned about a lot of really cool tools I'm excited to use. I'll talk about one, which we're developing. And so just to introduce this, I'll start with maybe the problems it's intending to solve. So as Corey nicely introduced, machine learning is really becoming ubiquitous in HEP for a lot of different applications, classification, reconstruction, simulation, and so forth. And so we are basically trying to help people who want to get started and try to actually use machine learning in this field, and particularly those who may not already be very familiar with the data sets and the ecosystem right now to do this kind of research. So those who are coming out of the field, for example, or who just aren't, keeping up to date with the latest file formats and how data is represented. And so it's designed to make it easy to get started with this kind of research and focus on actually the model building and training rather than, dealing with data and metrics and so forth. And so it's a way to get started. It's a way to have easy metrics to evaluate your results, standardized, and also allows us as a collaboration and as a community to be able to reproduce and compare results between different models and projects. And JetNet is a solution to these problems, or potential solution with easy to access data sets, standardized metrics, and more utilities to ultimately improve accessibility and reproducibility in this area. And just as a disclaimer, this is still, mostly just starting out as a project with currently a limited number of data sets and metrics. And any feedback or contributions to improve this are very welcome. Right. So yeah, today I'll just go over some very simple things you can do with this library, which is to load one of the data sets included, and to just look at it and visualize it using some of the utilities, and then finally actually prepare the data set with by using a PyTorch data class and in preparation for training a model. And so just to start with, we can just import one of the data sets which we want to use. So here I'm choosing JetNet just because it's the smallest and easiest to work with. So we can import this, and before trying to load anything, we can just look at the features available for the particles and the jets. And I should mention right now the data sets are all point cloud based data sets for jets. But again, one of the things I'd like to emphasize is if there are features or data sets or anything which you want to be able to use with this library, we're very open to any requests or contributions. But yeah, so we can import this and just print out the features available. So the 3 kinematic and mask features for the particles. And this jet type, kinematic features, and number of particles is available for overall jet features. And then we can, looking at this, actually load the data directly by calling this getData function and feeding in these arguments. So we can specify the jet types we want. So JetNet allows us to specify, the specific types of particles which produce a jet, the data set directory, and we can select which particle features we want to use if we only want the subset, for example. So here selecting just the kinematic features, the number of particles we want per jet, and selecting the subset of jet features. And so we can run that and load the data. If you're following along, it'll actually download the data set for you. I already downloaded this here just to speed up the demo, but it's a pretty small file, so it shouldn't be too long. And then we can print out some of the data and just look at it directly. So we can see I'm printing the 10 highest momentum particles and their 3 features, and the jet features, which we asked for, are shown here. Right. And instead of looking at it just directly, we can visualize these jets as images. So using this toImage function in this library, I won't go over all the plotting code, just showing that we can pass our data, this particle data, into the toImage function, and we can get out of it these jet images, basically visualizing the gluon jets, the more complex top quark jets and W boson jets. And we can also use this other utility to calculate overall jet features just from the particle constituents and plot those. So we're feeding in the particle data, it's jet features function, which is actually using awkward array under the hood, and extract the mass and plot it here. And so we see that everything is as we expect for the gluon jets, the top quark jets with the top and the non-fully merged jet peaks, and the W boson jets. Right, so this is just show a very easy way to load the data. So the point is that we shouldn't really have to worry about messing around with data. We can just do this quickly with almost a single line of code and move on to actually training our model. And for training our model, usually you have to do some kind of preparation to use it with one of these libraries, like normalizing the features, perhaps transforming them in some way, and using, for example, a PyTorch data loader and dataset class to run a training loop. And so these 3 things are provided for you or are made convenient. So all of our dataset classes inherit from the PyTorch dataset class. If you're familiar with the Torch Vision libraries, for example, they provide similar functionalities of being able to transform your data. So we thought, why not offer that as well? And so this is an example of doing some of these things. So I'll go over these arguments again for this example. So again, selecting some jets, selecting our particle features and so forth. But I'll emphasize this option, which is this normalization option. So it's this type of normalization we include, which is basically doing a linear transform of all our input features. And with this normal option, it basically automatically sets them to 0 mean and a unit standard deviation, assuming a Gaussian distribution. And we can select which of the features we will actually want to normalize. And so ignoring the mask feature, for example. And one other thing which is pretty common for classification tasks, for example, is to try and one-hot encode the class, the jet type. And so this we can use this transform input and specify an arbitrary function to transform each input every time we try to retrieve it. And so we can specify all those, and also JetNet can do the training and validation splitting for you if you so choose. So we can specify our train and validation data sets, and we can print out these data sets and see everything is specified as we expect. And we can also look at the data samples directly. And just note that indeed the features have been normalized and the jet type has been one-hot encoded. Okay, yeah, that was a pretty quick lightning demo as expected. And we can basically feed this into a data loader and start training. And some more things we can try, if you'd like, is looking at using some of the other data sets provided, like the top tagging or the core gluon data sets. Actually using this in training a machine learning model. We hope to have a tutorial on this soon as well, and using some of the metrics we have for evaluating generative models, for example. Yeah, once again, thank you for the organizers and thank you everyone for listening. I hope there is time for some questions.
Thanks a lot. Very interesting library. So I have one small question is, the library is called JetNet, and you mentioned several chat-based data sets, but in principle, it seems to me that there's nothing really specific about chat. So can this also be used for other data sets where you have just a set of particles that maybe are a bit more distributed in space and not clustered to a chat?
Yeah, exactly. Yeah, that's the goal. It's the hope is to be able to expand it to any type of data sets, including calorimeter showers as well, and full events. As this is just as it's starting out in proof of concept, we started with jet data sets, which are very popular for machine learning use cases.
Okay. Thanks a lot.